Right. Alyssa, hello, good morning. How are you? It's good to see you again, Alyssa. I haven't murdered. I did. Check that. Yeah, okay, I'm good. Ooh, all right. Oh man, fighting strep, yucko. That sounds pretty bad. That's no fun. You trying to fight strep throat. Hope you feel, yeah, I do hope you feel better soon on that front. Strep is no bueno. Hey, Parrish, my friend, how have you been? Haven't seen you in a while, my man. Everything has been going very well. How about yourself? You finished your linear algebra? Okay, great. How'd you think you did? Did you feel pretty good coming out of the exam? Decently? Well, I think I'll take the word decent over being dejected. So I'm gonna cross my fingers for you, Parrish, and hopefully that you did better than decent. Oh, really? That's good. I'm happy I was able to help in some way. As long as it helped you do better and helped you learn, hey, why not, right? Look, at the end of the day, I'm just happy that you're better off, Parrish. That's what I'm happy about. All right. You got any plans for the weekend? Anybody has? Yeah, yeah. Unfortunately, a lot of online classes are going to be that way, where it's a little bit more student oriented. So the professor barely talks to you. Yeah, well, that's not good. The professor has to talk to you a little bit at least. Barely talking means that they can't get certain points across that you don't understand. Like that doesn't make any sense. You might as well just not show up to the class. I understand the students learning on their own, but yikes. I can see how frustrating that can be. We're going to start here in a minute, everybody. Okay, so wait for a few more people to come on in. Yeah, that makes no sense why. I mean, I know the flipped classroom approach, but yeah, barely talking doesn't really justify that. Okay, that's not a problem. I'll see what I can do to help you out, okay? Just anything I can do to help, you know? That's what we're here to do. All right. Well, I do got to get started though. So let me go ahead and get going with that at the very least. Okay. All right. So hopefully we'll have a few more people come on in, but we got to get started here. So let's go. All right. Okay, let's get started today. Welcome back to Thursday. All right, end of the week time today. So today we are going to be finishing up, hopefully finishing up, chapter 4 here today, talking about some decimals stuff, okay? So that's what's on the agenda here for today. All right, you have a wonderful weekend. Um, come on back anytime, Parrish. You're always welcome. All right, so today we're going to be going ahead and talking about how to divide decimal numbers, okay? So last time we talked about taking a decimal and dividing by a whole number. But today we're going to do kind of the other half of section 4.5, which is essentially effectively just taking a decimal number and dividing it by, say, another decimal number. All right, so let's go ahead and put this on here. Good. So in this part here, we're going to so we're going to divide decimal numbers by decimal numbers. And so we're going to take a look at several examples here about how to go ahead and do that. But before we do that, we need to go ahead and talk about the steps about how to go ahead and divide decimal numbers by other decimal numbers. All right. Now, just really quick here, what's an example of this really fast? An example of this is going to be, and I'm going to move this over to the left now. So an example of this is going to be, let's say, I'll take that example that was over there. Let me get this. Okay, where we had, say, 0.003, and then we had 27.69 here, say just like so. And we wanted to figure out, oh, okay, well, what's exactly that going to be at the end of the day? Just check that. Okay, that was correct. All right. So, how exactly do we go ahead and solve for this type of problem? We're going to need to go through a few steps here. Now, last time when we talked about dividing by whole numbers, we could just easily line up the decimal places and then just do our regular division. However, unfortunately for us here in this instance, we don't have that option just yet, but we do want to make our way over to that option. However, we're going to need to do something first. All right, step one. All right. Remember that 0.003 in this problem, remember that is what we call our divisor. Okay, so that's what we call our divisor here. Okay. So what we're going to do here in our divisor, or the number that goes on the outside, okay, we're going to move the number of decimal places to the right on the divisor, aka the number on the outside, as move the number of decimal places to the right on the divisor as many as you can until we get a whole number. Okay, so how many decimal places are we going to move on the outside? Well, we want to keep moving to the right as many decimal places as we can until we get a nice, clean, whole number left on the outside. So let's take a look at what that means here at the very beginning. Okay, so what that means is that here, I'm going to take this decimal point, I'm going to move that over 1, 2, 3 places over to the right. So I'm going to have a nice whole number here of 3 on the outside. Okay? That's what I have to start with here in step 1. I'm just moving it over as many decimal places until I get a nice, clean, easy whole number. It should be easy. Now, there are consequences for me to do so. Remember, everything when it comes to algebra is always a balance. And this, once again, is going to be another classic example of where we're going to be doing this so-called balancing. Okay, so step number 2 is move the number of decimal, move the same number of decimal places as you did in step 1 to the right of the dividend, i.e., aka the number on the inside. I'm going to put a little note to this here. Note, if you have blanks, just put a 0 in those places. So let me show you what we did here, all right, just to kind of break it down a little bit further. In this particular spot here, to get from 0.003 to 3, we moved over 3 decimal places here to the right. So I'm just going to make a note here. We moved 3 decimal places here. Okay, we threw 3 decimal places to the right. We always move right here, by the way. So, but just for the highlight of this example, just showcasing how that works. Now I'm going to do the same thing here on the inside as well. So I'm going to go 1, 2, and 3. And I'm going to put the decimal point on here. Now if you see here, I have a blank out here. So I'm going to put a 0 in that spot to fill in the blank. So I move 3 decimal places to the right, and over here, I once again do the same exact thing. And again, I'm just balancing it out. What I do on one side, I'm going to do on the other side. So in reality, what I have is, here in step number 2, is I have the 3 on the outside, and then finally on the inside, I have 27,690. Okay. And if it helps, okay, as you see where the decimal point is, you can put the decimal point again wherever it lands, okay? So wherever the decimal point lands, like in this case, the decimal point landed here next to the 0, so you can line that up just like so. If you need to add extra zeros to do the regular division after that, go ahead and add extra zeros after that if necessary. So again here, let's put a second note to this. Okay. Add the decimal point and any extra zeros as necessary. Finally, here for step 3 is just, do the division. Okay. So we're just going to now do the division after we put all that together. Okay, so pretty much the same old regular stuff that we talked about before. So let's look at step 3 here. We got 3, and again, let's see what we got here. We got, again, 27,690. Again, I'll just put in the few decimal places if we need them. I just put it in just in case. Doesn't mean we will use them. It just means that we may use them. Okay, so let's just go down the line here and see what we have. So 3 doesn't go into 2, but it goes into 27 9 times. So 9 times there. So that's going to be 27. It's going to be 0. 3 bring down the 6. 3 goes into 6 2 times. We get 6. We get 0. Bring down the 9. 3 goes into 9 3 times. Get 9. 0. Still bring down the 0, guys. Don't forget about that. And so we have 0 here, which is going to be our remainder. So it looks like we don't need the 3 extra zeros here, which is fine. But our final answer here is going to be 992.30 is going to be our final answer for this particular problem. Okay. All right. Are there any questions about that? No. Oh yeah, of course. Well, that's going to be a lot of our examples here today is going to be doing things just like that. So absolutely, 100%. All right. Well, definitely let's acquiesce to that. Let's do some more examples for sure, and let's see what we can do with that. Okay. Let's try another one. Okay, so we're going to try this second one here. We're going to try again we're going to try 1.8072 divided by 0.06. All right, so let's go ahead and write that down first and foremost. So I'm going to go ahead and erase this and go ahead and start on that. So, okay. Okay, so let's go through the steps here once again, and we're going to be able to solve for this division problem here. Okay, so I'll put this on the full screen here for this one. Okay, so let's go through the steps here once again. Let's do the first step here. So step 1 here is for us to move the decimal place on the outside until we get a whole number. So so let's just take a look at 0.06. Okay, let's just take a look at that. How many decimal places to the right are we going to move until we get a whole number on the outside? How many decimal places are we going to move to the right to get a nice whole number on the outside? actually shrink this down a bit. Okay, that's correct. The answer definitely is 2. All right, so we're going to move 1, 2. Okay, so that's correct. We move 2 decimal places here in this instance. So the number we have on the outside here is the number 6. Okay, so we got 6 on the outside here. Now, how many decimal places do we need to move on the inside here? How many decimal places need to be moved on the inside here? So let's ask this question here. How many decimal places do we move to the right on the inside here? Hmm. Four? Okay. So they said 4. Okay, now if you moved it 4, that's how we would get a whole number out in the inside here. However, I want to point this out here. This is why I asked this question, because this is actually the part that actually confuses the most amount of people, and that's fair. Okay, so this is I want to make double extra sure we just again correct, smooth out those wrinkles. The big key to understand about what I put in here for step number 2 is this. You're going to move the same number of decimal places as you did in step 1. So let me actually highlight this here. The same number of decimal places. Remember, everything in algebra is balance, okay? Okay. Always remember balance. This is one of the most important things into understanding this class, the next class, and the next class up, and so on and so forth. Balance is one of the biggest keys to understanding how any algebraic concept is going to work. Okay, so the big key here is that we want to move the same number of decimal places as we did in the previous step. So let's answer the question one more time. Okay, let's try it one more time here. So let's answer this this question one more time. How many decimal places do we move to the right on the inside here? There we go. All right. That's correct, okay? Nice job, J-Dragon. So you can see like why it's not 4. It's actually 2 because we're balancing things out, right? What we do on one, we got to do the same on the other, all right? So we're going to move 2 decimal places over to the right here for the number on the inside here. So we're going to take this decimal point. We're going to go 1, 2. And this is where the decimal is going to end up, right here. Okay, so what we have here is we have, again, 180.72. Okay, before we move forward here, excuse me, before we move forward here, are there any questions about that? So any questions about that part there? I want to be sure that that part's the most understandable part because it's the toughest part. I, okay. Remember to type no in the chat if you don't have any questions. Or again, if you do have a question, please type the question. Please type the question out. I prefer if you guys type no in the chat if you guys do not have any questions, okay? Otherwise, otherwise I'm not sure if I can move on or not. You guys gotta tell me. Nope. Okay. This is section 4.5, Jonathan. This is basically the second half of section 4.5 though. There's just a lot in section 4.5, so okay. Let's go ahead and see what we can solve for here. All right, so we got 6 and 180.72, so let's do the division here. I'm going to line up those decimals just like so. All right, and we're going to go 6 into 18. How many times does 6 go into 18? How many times does 6 go into 18, ladies and gentlemen? Twice? 2 times? So 6 times 2 is 8. Is 6 times 2? I think we're missing one more there, Alyssa. 6 times what is 18? There you go. All right, good. That's right. All right, very nice. So we go 6 times 3 is 18. That's okay. I know everybody's a little still asleep, but it's good for me to just not talk the whole time. Listening to my own voice is rather boring. So that's why I encourage you guys to participate. Um, so we have a 0. When we subtract, we bring down another 0. 6 goes into 0 times. So we're going to, again, that's going to be 0. I'm going to bring down to 7. Okay. 6 goes into 7. 6 goes into 7 how many times? Once. Okay, good. So we can put a 1 here. So you get 6 times 1, which is 6. we get 12. 6 goes into 12 how many times? Twice. Okay, good. All right, so here we get a remainder of 0, which is what we're looking for here. So that's our final answer here, is exactly what you see up top, 30.12. And there we go. Cool. Excuse me. Are there any questions about that? No? Okay. That's fine. All right. Okay, so next thing we're going to do here is let's go ahead and do a few more problems here. Okay, so let's take a look here at, yeah, that should be fine. Okay, so I'm going to have you guys try a problem on your own. Okay, and I'm going to go ahead and move it over here. So let's do letter D here. So we're going to do 8.1 divided by 0.025. Okay. So again here, if you want to set this up, remember 0.025 would be here on the outside, and 8.1 here would be on the inside. So let's take a couple minutes or so, all right? And let's have you guys try this problem out. And once you have an answer there, go ahead and type that out in the chat. Okay? Let's go ahead and give it a go. Again, once you have an answer there, go ahead and post it in the chat. Okay, so you got 324 there as your answer from J Dragon. Okay, let's see if anybody else wants to chime in there before we review this problem. Which problem are we solving now? This one right here, 8.1 divided by 0.025. Doing it by hand way there. Okay, you said 36, okay. All right, so a couple of good guesses there. Let's go ahead and take a look and see if which one of those answers is correct. Okay. And if you didn't get it right away, that's okay. We're going to go ahead and review this here together. All right, let's do it. Let's erase this here. Okay, so first things first here, we're going to go ahead and move this on the outside here. We're going to, again, go 1, 2, 3. Okay, so we move 3 decimal places here to the right on the outside. So that looks pretty bad. So 3 decimal places, so 3 dp. Okay, so what we're going to have here is 25. All right. Now, remember, on the inside, we're going to move the same number of decimal places on the inside here. They say 32.4. Well, let's see if that's right. So we're going to move the same number of decimal places. Remember, everything in algebra is always a balance. So we're going to have, again, 1, 2, 3. So in this case here, we have 2 blanks. And since we have 2 blanks here, we're going to put in 2 zeros. Again, we'll have a decimal point here on the outside. So in reality, we have 8100 here, again with our decimal point here on the outside. So we're going to just line up the decimal points so we don't have to worry about that later. And then I'm just going to go ahead and do our regular old division. So 25 goes into 81 correctly 3 times, so that's going to be 75. Subtracting that, we get 6. So we get 60 here after bringing down that 0. Okay, next we figure out how many times 25 goes into 60. That's obviously going to be 2 times. So we get 2 times 25, which is 50. We get 10 and bring down the 0. That'll lead us to 100. Can never draw those arrows right. All right. All right, and then we're going to put in a 4. 25 goes into 100 4 times. So get a remainder of 0 here, which is fine. Okay, so then our answer here is indeed going to be 324. So 324 here is the correct answer to this problem. All right. So a little close there, Guthricks. But again, remember that we do have to move over 2 times instead of the once. So that's why it's 8100 as opposed to 810. I would agree if it was 810, 32.4 would definitely be correct. Because we had to move that 1 extra decimal spot, well, that's why it was 324 instead. Okay. Any questions about that? Yeah, I would like you to show for like a, yeah, of course. You could do the calculations there on paper. So again, for like tests and stuff, I prefer it to be on paper. In these cases here, um, if you're doing a test here, again, you have to show off the work. So this is the proper way to kind of just show off the work for that particular problem. Okay. So can you add zeros to the number if it doesn't have enough spaces to move over? Yes. So as you see here, we had the blanks there, right, Alyssa? Like these two blanks once we moved over three spots to the right. So yeah, that's exactly what we do is we just plop in zeros wherever we see those blank spaces. If you want to add, now it's your option here. If you want to add like extra zeros to the right of the decimal point, you can, and then bring that down as well. So if you need it, it may or may not be necessary. It just depends on the problem that you're given. We're going to do another example where that's the case, but yeah. You definitely got the right idea there. But let's try another problem here then. I think we need to get another look at another type of problem here. We've kind of acknowledged, but not actually done. So let's look at letter E right here. Okay, so let's go ahead and do that one there. All right, so we're going to do this one here together. We got 7.3. 7.3. What am I doing? Just 7. 7 divided by 1.3. All right. So in this case here, 1.3 goes on the outside and 7 goes here on the inside. Okay. Now, really quickly here, just to kind of showcase a couple of things. First and foremost here, if you just have a whole number here on the inside, just like so, you can go ahead and just put a decimal point right next to that number. Okay, just like so. So if you say, hey, you know what, I don't know where I'm going to start here in a problem like this in terms of decimals on the inside here, just go ahead and plop in a decimal next to the whole number. Okay, so let's go ahead and put that as a note as well. So note, okay. So I just put the note here, put a decimal next to a whole number on the right if you are dividing it so you know where to start. So that's just a little, an important note definitely. You're like saying, "Oh, I don't know where I'm going to be moving right from. Where am I starting from?" You could definitely start from there. Okay. Now in this case here, we're going to be moving to the right by one spot. So this is one decimal place to make it 13. Of course, then we have to move one decimal place to the right of this as well. So this is going to be 70. Now we put the decimal point here to the right, and we're going to add a few zeros. Again, if it's necessary, we can add a few zeros. So let's see what we get once we divide these out. So if we take a look at 13 and 70, you'll find out that 13 goes into 70 3 times. So it's 3 times? Oh, actually, I take that back. Sorry, I'm thinking 39. Let's see, how many times? 5, 6, not 6, 5. So 5 times. All right, so let's go 5 times there. That's my bad. I was thinking of the wrong number. All right. So 5 times 13 is 65. Again, now we still line up the decimals here, but now in this case, we actually do have a reason. We do have a reason here for these extra zeros on the outside. So let's see, how far we have to go for this. So 13 goes into 50. Now I know for a fact that goes in 3 times. So that's going to be 39. Subtract that, that's going to be 11. And then we'll go down here. So we'll get 110. 13 goes into 110. Let's see. 9 times? No, that's, nope. 8 times. That's 100. Okay. 8 times is the correct answer here. So 3, 8. That's going to be 104. So you get 6 and 60. Okay. 13 goes into 60 4 times. So that's 52. Okay. Now, this is where I'm going to technically stop because I'm pretty sure we could keep going on for quite a while. Okay, I mean, really, it could go on for quite a while here. We could get 384, blah, blah, blah. Now, what could happen in these problems here, and the reason why I wanted to do this problem specifically, is because the fact that in this particular case, sometimes it will ask you to round to the nearest something. Now, we talked about this last time as rounding to the nearest type of number here. In this case, it says round to the nearest hundredth. Okay, that's what it says here in this instance. So if we if we round to the nearest hundredth, so let's round to the nearest hundredth here. Oh, well, it'd be helpful if you could see that. Let's zoom that up there. Okay. So let's take a look at the number here of 5.384. Because again, I could technically keep going here, but again, I'm rounding to the nearest hundredth. Can anybody tell me which number is the hundredth spot in this decimal? Which number is the hundredth spot in this decimal? Okay, so he says 5.389, or 5.39. So here's a question for you. Which is our hundredth spot? Is it the 5, the 3, the 8, or the 4? The 8, that's correct. Okay, so the 8 here is absolutely right. So again, we're going to go ahead and circle the 8 here. That's in the hundredth spot. And we're going to look to the right of that particular number here. So that's 5.3. So again, because this is 4, this 8 is going to stay the same. That's going to remain an 8. So our final answer here, if we're rounding it to the nearest hundredth, which it may ask us to do in some of the homework problems, will be correct 5.38 as our final answer. Okay. Okay, Are there any questions about that problem there? Any questions about that? No? Okay. All right. Okay. Okay, now the next part here that we're going to talk about is estimating before dividing. Now we did talk about this pretty much in almost every section where we estimate a little bit before dividing, and then we divide to find the exact answer. Okay, so there's going to be an estimate, there's going to be a exact. Okay, so it's going to be kind of a two-part problem here. Now, let's at least remind ourselves a little bit about what what this is talking about here. Yes, thank you. Okay. Let's just go with the word estimating. That'll be fine. Okay, now specifically here, the estimating that they, sure. Oh, no, no, that's fine. Actually, that's what we're going to be doing right now because that's exactly what it asks us to do here, Hannah. Exactly, front-end rounding. So in this case here, we're going to be talking about here specifically, as the question, as your question asked, we're going to talk about front-end rounding. Now we've talked about this before. We've actually talked about this before in previous examples, but let's remind ourselves, because of the question here, about what front-end rounding means. Let's take a look at the question that we see up here on the handout. So we see 580.44 divided by 2.8. Okay, so what we want to do here, let's talk about the key of front-end rounding. We're going to look at the very first number and round to that particular placeholder. So what does that mean? Well, let me write this down on the paint tool here, 580.44 divided by 2.8. So I'm going to write that down here, and I'll show that off here. So let me get this set up here. Okay, so now that we have that, I'm going to go ahead and move this over here so we can look at that together. So first, if we're doing front-end rounding here, let's take a look at the first number here, because each one is going to be a separate case. So 580.44, I'm going to look at the very first number here. Now let's take a look at this first number here of 5, okay? Now we're going to round to that particular placeholder. Now 5 here, as we would just say this would be, say, 580.44, i.e. we're going to round to the hundreds place. So we're going to round to the hundreds. Because that's where the 5 is located. So the 5 is in the hundreds spot. So if we rounded 580, again, we want to use the 8 next to the 5 here, by the way. All right. So what would 580 round to the nearest hundred be? What would 580.44 round to the nearest hundred be? That's right, 600. Absolutely spot on. Okay, so now we've front end rounded 580.44. All right. Now we're going to answer the same question here once again for 2.8. This time, though, we're going to circle the 2 because that's our very first number that we see there. Again, the 2 is in the 1 spot. Okay, so we're going to round to the 1s. Again, we're going to underline the next number over. It doesn't matter if we have a decimal or not, okay? We're still going to follow the same pattern here. So regardless of wherever the decimal is, the decimal actually plays no role in terms of the rounding. So right side, left side, it doesn't really matter. So if we rounded 2.8 to the 1s, okay? How do we round 2.8? What does that round to? That's correct, right? We have an 8 next to the 2. So again, because that's 5 to 9, this 2 will round up to 3, right? Okay, so this will round up to 3 as a result. Okay, are there any questions about that for the front end rounding at the very least? I hope that answers your question there, Hannah. We'll be doing a couple more examples, but okay, great. Now, what they're going to ask you to do here is, of course, the very first part of the problem is they're going to ask you to go ahead and divide. So divide using the estimated numbers. So if you went ahead and divided this out, and again, I'll let you do this one on your own here. They're just going to ask you to say, hey, can you tell me, 600 divided by 3? And there's like, okay, I just need you to tell me what 600 divided by 3 is, and then you'll do that out, and that'll turn out to be 200. So I'll let you do that on your own. That's really not too hard. Again, you could do some simple division with that to get 200. Easy enough. The thing that I want to focus on, though, is the actual exact answer here, because that can take a little bit more time. So we're going to go ahead and talk about how to do that here once again, all right, in this particular instance. Okay, so let's go over that part here in this case. Okay. So in this instance, let's go ahead and set up our problem here, our original problem, this guy, the exact numbers. So we're going to put 2.8 here on the outside, and we'll go ahead and put 580.44 on the inside, just like so. Okay, now again, we're going to employ the same techniques here. So we're going to move, in this case, 1 decimal place over to the right on the inside. And of course, we got to do the same thing. Again, everything's a balance. I got to do the same thing here on the inside as well. Always a balance. So we're going to have 28 on the outside, and we're going to have 5804.4. And again, if we need to add any extra zeros, we can. So let's, just in case, I'll add a couple zeros. I don't know if we'll need it, but again, it's purely optional if you feel like you may need it. And we're just going to now go through the problem here and see what we get. Simple enough. So let's take a look at 28. So 28, again, we have 5804. Okay, so just going over the things here. 28 goes into 58. Let's see, how many times? How many times does 28 go into 58? How many times does 28 go into 58? Okay, 2. Good, good, good. So I'm going to go ahead and put a 2 up here. Again, you could just do, if you're not sure, yeah, if you're not sure about how many times, you could just do 58 divided by 28, and you're going to get 2 point something something. You could just take that 2, and, let's say you put that on the calculator there, you do 58 divided by 28, then you could put a 2, and so that 2 you get there. Now you get 2 times 28. If you do that out, that's going to be 56. So we got a 2, and we're going to bring down the 0. Now 28 does not go into 20 at all. So again, we're going to put a 0 here because, again, 28 does not go into 20. So we're going to subtract here. We get 204. Okay. So let's ask the question here. 28 goes into 204 how many times? How many times does 28 go into 204? This one's a little tough, but go ahead and do it again. How many times does 28 go into 204? 7 times. Okay, that's right. Nice. Okay, so let's do it. See, 7 times 8 is 56. And then we have 14 and we got 19, so 196. Okay, great job. Okay, now this is going to be 8. So we do 204 minus 196. We'll bring down the, again, we have the decimal that we have to line up here. So let's line up the decimal just like so. Let's bring down the 4 here. Okay. And how many times does 28 go into 84? Okay, 3 times. So we have 3 times here, so we have 3 times 28. That's going to be 4. 3 times 2, 6 plus 2, 8. So that is actually exactly what we're looking for here. Perfect. That nets us a remainder of 0. So our final answer, our exact final answer here, again exact, not the estimated one, is 207.3. And that's our exact final answer for this problem. Great. Okay, any questions about that problem there? Okay, let's go ahead and shrink this down a bit. Need to look at another type of problem here. Okay. Okay, I don't think I'll get to that. Oh, actually, I may get to that. It's just, yeah. All right, that's fine. Okay. Okay, let's take a look here at another problem. Okay, this time I want you guys to go ahead and give it a try. Okay, so now that you have the previous problem, let's go ahead and put in another problem here where you do the estimation, the front end estimation, and then the actual exact answer. So Again, just so it kind of reflects what you see on the homework there. So let's do, what is that? No, that's not what I want to do. Okay. Let's see, do they want me to, let me just check this here. Okay, I guess, sure. I guess they're gonna give us the exact answer here, so let's, I guess, do a little bit of estimating. That one is not what I want to do. Yeah, let's do this one here, though. 9.0584. Okay. Oh, this isn't the exact answer, actually. So, divided by 2.68. Okay. So, first and foremost here, estimate both of these numbers here using the front end rounding. Okay, so just as a reminder here, you're going to look at that first number. All right, and round with that first number there. Okay. Okay, well, let's go through this really quick. What is the estimation of 9.0584 if we were to do front-end rounding here? What would be the estimate for that? All right, 9. Good. And how about 2.68? What would 2.68 round to using front-end estimation? 3. Okay, great. All right, that's absolutely right. So again, the 2 is what we look at here, but since it has a 6 next to it, we round that up to 3. Okay, so the easy part is we do 9 divided by 3, and that is equal to 3 outright. Okay, so that part, not too hard. Now I'd like you to go ahead and give a try here to the actual division. So we'll go ahead and put this out here. And 9.0584. Okay. So let's go ahead and have you guys spend a few minutes on this particular problem here. Okay, so this one here may take a little bit of time. All right, again, if you need to use the calculator to figure out how many times the number goes into another, that'll be pretty helpful for this problem here. Okay, so uh, let's go ahead and take maybe about 2 or 3 minutes, and then once you have an answer for this, go ahead and post that in the chat. is that going to be? Check that. I better. So Ola got 3.38. Okay. All right, let's see if anybody else comes with any other answers. Get anybody else? Got this. Okay. Okay, that's fine. All right, that's okay. All right. Okay. Sorry, I just needed to check on something there. That was rather important. Let me actually check one more thing for you guys. That is also rather important. Okay, that's fine. That is okay, doke. All right, that is not a problem. All right. Also 3.38. All right, perfect. Let's go ahead and take a look and see if we can confirm that that is indeed the answer here in this case. Okay. Okay. So let's go ahead and put, again, 2.68 here is on the outside. Actually, I already put it down there. So let's do that. So we move over here 1, 2 decimal places here to the right. So 2 decimal places. We also move 1, 2 decimal places here over to the right. Okay, so here we're going to have 268 on the outside. And on the inside here, we're going to have 905.84. All right. We want to figure out how many times 268 goes into 905. And again, you could do that on the calculator. You're going to get here 3 times. It's going to be 3 point something something, but we don't care about the decimal part. We just care about the 3 part. Okay, so we do 3 times 268. Again, you could do that on the calculator if you so choose. Okay, so you get, again, 268 times 3 would be 804. So we're going to get 101 here. Again, we're going to put the decimal right here. We're going to bring down the 8. Repeat said process to 1018 divided by 268. Again, that's going to be 3 point something something. So that's going to be, again, another 3. So again, we take 3 times 268, which is the same 804 that we got from before. All right, so we do 1018 minus 804, so we get 4, 1, and 2. So 214. We'll bring down the 4 here. And we'll go ahead and see how many times does 2144 goes into 268. So again, you could use a calculator for this part here. 268 is a pretty large number, so we exactly get 8 times. So that's going to be exactly 2144, given our remainder of 0, which is what we're looking for. So that is the correct answer here. 3.38 is spot on. Okay, any questions about that? Any questions at all about that particular problem there? No? Okay. All right. Okay. All right, so that is going to be that for estimating. Now, the last part here talks about using order of operations. So, order of operations is, now, unfortunately, we're not going to have like too much time here to do this example. So I may actually just hold off on doing that here for today. But order of operations works pretty much the same as your regular order of operations, i.e. you still are going to use, again, your, please excuse my dear Aunt Sally. So again, let's not forget at least order of operations that I can at least write in. That part I can do. So order of operations doesn't change. It never changes. So again, parentheses, exponents, multiply, divide. Remember that multiply, divide here was on the same exact rank. And add, subtract. Okay. So parentheses, exponents, multiply, divide, same rank, add, subtract, same rank. And we go ahead and just, again, evaluate this the same exact way we've done before. Again, 6.3 squared, for example, in this first example here, 6.3 squared is basically going to be just like if you write it out here really quick. Yeah. So if we do 6.3 squared, that's going to be 6.3 times 6.3. All right, and then you'll need to figure out what that is using the same rules that we've talked about, say, for decimal multiplication, and then that's what you're going to get for 6.3 squared. So again, if you did that out here, and I'm going to do this really quick because so what you should end up with here is 39.69. So is what you'll end up there. But again, same techniques, same everything, nothing changes. So, go ahead and give those problems a try. What I'm going to be doing is I'm going to start from this last part here for next time because we're running out of time here. So we may end up doing just an example or so from, uh, doing order of operations. And then I may talk something in 4.6 maybe, or maybe not. I'm not sure. I may not just have time for it, to be perfectly honest, because we do need to get into chapter 5. Chapter 5 is going to be our next chapter here. So just to give you a little bit of a heads up here and why I was checking here kind of in the middle there, is chapters 4 and 5 are going to be a combined test there. So it'll be chapter 4, chapter 5, and that's because a lot of chapter 5 is going to use some parts of chapter 4. So and chapter 3. So we're going to be talking about that here in chapter 5. So chapter 4 and 5 will be its own test. So and then we'll do like chapter 6 and chapter 9 and stuff. So um, that is what is on the agenda here for the upcoming time. So next time here, next week, we're going to do, starting with order of operations, we'll do an example of that. We're going to start chapter 5, just start talking about that. And hopefully we could get through section 5.1, maybe part of 5.2 as well. So that is what we're going to be doing. Does anybody have any questions about that? Oh, right. Sorry. One more thing. I will be looking at your tests here eventually this weekend. When is the test over chapters 4 and 5? Not sure yet. It will be in maybe the chapters 4 and 5 test. Let me see here. I can give you a decent idea there, Hannah, because that's a very fair question. Uh, So I want to say here, Hannah, that's gonna be um like in 2.5 weeks, maybe 2.5 weeks from now. Um, maybe something like that, or maybe 3 weeks. So we'll say 2.5 to 3 weeks to be the latest estimation. So because we have to get through chapter 5 as well. So we'll say that that's probably a bit better. 2.5 to 3 weeks is probably where I'm looking at where the chapter 4 and 5 test is. If it's earlier, of course I'll let you know, Hannah. I always let you guys know well ahead of time, like a week ahead of time. So I know it's not next week for sure. So definitely not next week. But yeah, we'll see. We'll see exactly where we are. It just depends how fast or slow we go. So yeah, that's basically where we're at. Any other questions you guys have? So if you're keeping track here, the homework is again just we just went over section 4.5 here. It's again a pretty detailed section there because of how in depth just taking care of that one concept is going to be. So uh, that's essentially what we're doing there. All right. If there are no more questions here, that's where we're going to end off here for today. I want to thank everybody coming out here for the stream once again, very, very much. I wish you all a very good morning and a good afternoon, and have a very great weekend. Everyone, please stay safe. Please stay healthy. All right. Thank you. You have a great day as well, Alyssa. Please stay safe. Please stay healthy. And for those of you who want to stick around for the 11 o'clock class, I'll be back in 10 minutes. All right. Everybody, we'll see you later. Have yourself a wonderful day. All right. And weekend. All right. See you later, everybody. All right. Take care. All right. Bye.